Okay, so welcome to Math 212. First thing I'll mention, we are recording right now. So I record all of my live lectures, put them up on my YouTube channel for various purposes, some of which we'll talk about in a few minutes. But for legal reasons, I'm required to notify you that we are recording audio right now. So if you ask a question or make a comment or something like that, you've been officially notified that your voice might be recorded. Okay, and what we recorded will go onto the YouTube channel. Okay. All right, so couple things we're going to go through. These are my notes for first thing we'll do in the class. If you're a math major or minor, come talk to me. Probably this is the right course for you. Some semesters, some courses, not so much. But nevertheless, even though this is almost certainly a good choice for you this semester, good idea to come talk to me. Okay. All right. One of the big things that you need to know about this class is the location of the website. If you go there, which is this page right here, and then you notice I have last semester's web pages still up. That probably won't remain very long. But click right here at the top, Math 212. This is the website for our section of Math 212 for this term. So this is the main repository of information about how this class will run and policies and procedures and stuff like that. So make sure that you have access to this page. You have a homework assignment for next time, and that is to read various different things on the web page. So I'm going to say all of the main page. So going back to the web page here. So there's a bunch of stuff here. Look, it's various different things. Here is the syllabus. Here's some discussion about the grading system. Here's a discussion about additional homework problems, the lecture schedule, blah, 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 right? Bunch of different stuff. And rather than me going through and talking through all of that on the first day of class, it's just easier to have it all written down. So make sure to read all this stuff. Note the page is lengthy. And as I have commented here, especially the stuff at the bottom. So there's some stuff that I've added fairly recently. This recommendations concerning schedule. This is maybe a couple years old at this point, I suppose. But this is a list of things that I think you should be either doing or considering doing every day. So one of the reasons that I have this written down like this is that I think it makes a big impact. Oh my gosh, look at all those things. I'm supposed to do that every day? Yikes. Right? Yeah, there's a lot of stuff to do to really be up to speed, getting the maximum that you can out of the course. There are a lot of things that you should be doing every day, thinking about every day, etc. So anyway, read through all that. This business right here, advice on how to do well in this course, this used to be part of the first day class introductory spiel that I'm giving you right now. And the trouble is that this, these comments that I now have in writing, started off much shorter, and then over time, ideas occurred to me, things that I should tell you, first day of class, and so it got a little longer and then a little longer, and as of last semester, if I remember correctly, it took the entire first day of class. I didn't even talk about math on the entire first day of class. That's crazy, right? So it's now written down, but look, these are really important things. I want you to understand. For example, among your this isn't highlighted. Among your list of resources, I list you yourself first. Right? So you got to be in charge. You're in charge of your own education here. So take the initiative. Right? Be aggressive. Thinking about what you should do, etc. Notice that I have a bunch of stuff highlighted along in here. That's not intended to be. You only have to read the highlights. That's just drawing your attention especially to those things. But make sure to please read all of the comments here. There's a lot to say. Course expectations. There's a lot to say. Right? What are we going to assume that you're capable of when it comes to exam time? Why do we expect those things of you? Okay, a lot of stuff. And then there's a thing here about asking questions in class. Some students are maybe a little too hesitant to ask questions in class. Some students are maybe not sure should I ask this question here, or would this be better as an office hours question, or a right after class question. So there's some discussion here that I hope will help clarify. The big point here is that if you're not sure if you should ask the question in class, see both sides of the argument, go ahead and ask. And look, if it's better as an office hours question, then I'll just say, oh no, it's a good question. Yeah, let's talk about that in office hours. Right? But I don't want you to just ignore a question that you have. Okay. All right, so there's a lot of stuff to read. That's part of your first day assignment. Notice also part of your first day assignment, read all of the links at the top of the course information section. So here is a link on general policies. And it's a bunch of stuff, right? I mean, again, little details that are important for everyone to know, but there's too many of them to go through. The general comments. This is sort of generic advice about specifically how to do well in this course, generally how to do well in courses in general, and little things like notations that were encouraged, allowed in high school that I think are really bad notations, and I know that you shouldn't do in this class. Stuff like that. So anyway, it's all here, and a bunch of stuff. A lot to read. And then finally, exams, homeworks, and grading. There's a bunch of discussion about different things. Anyway, again, better to be read. Okay. Back over to here. A lot of stuff is written there. There's a lot of big talk. Take me seriously. I'll point out that there are some, especially high school classes, where they make a bunch of big talk about how, you're going to be challenged at a very high level. And then, well, maybe not so much in actuality. But in this class, it really will. And I know y'all have heard the rumors, right? Math 212 has a reputation. Everybody knows it's a hard class. Anyway, when I'm talking in the pages that you're going to be reading there about, I'm expect, a creative application of ideas. I mean that pretty literally. Anyway, okay. So make sure to read all of that stuff. There's also a bunch of links there. You don't have to read everything at every link. After all, that would force you to read the entire internet, right? But I want you to click around and see what's where, see what's available. So you'll know it's there at some point in the future if you decide you need it. Okay. All right. How are we doing? Anybody have any questions so far? No. Okay, let's talk about some logistical things. Let's talk about, again, a very important thing, the syllabus. So if we go back to the web page, note one of the first things is syllabus. Right here, and there's a link to the course web page. This is the math department maintained web page for the course, and right here you click, and there is the course syllabus. This includes all of the sections that we'll be covering in the course, and also all of the homework exercises that are assigned for those sections. Okay. Once we finish those sections, those homework questions are assigned. We'll talk about those logistics in a minute. Let's see here. The lecture schedule. So this is something I want you to probably ought to print both of these documents out, by the way. Or if there's a more modern version of that, put them in your such and such a folder on your iPads or something. Whatever gets you immediate, convenient access to these documents as soon as possible. Probably ought to do that. So let's talk about the lecture schedule. Here we go. Back to the web page. Right here, lecture schedule. Click on that. And I guess I'll make this a little, well, for the moment, let me leave it small. This shows pretty much everything we're going to be doing every day in the course. So now let me zoom in where we can see it better. Notice that here we are today, Wednesday, January 8th. The goal is to get done with page 3 in my lecture notes, because I'm going to be spending a bunch of time talking about logistics stuff. Okay. Okay. And whatever we finish, whatever homework, whatever sections are completed as a result of our getting through page 3, those will be listed here. Side note, it's not going to be any sections of the book because it doesn't do enough material. And those homework exercises on the syllabus will be due Friday, January 10th. That's this coming Friday. Again, good news, there are no such sections, so therefore there are no such homework exercises. So nothing's due at the end of this week. But you'll see here, now I have shaded January 17th. They're all in dark shade. You'll notice the pattern. Then the next Friday, January 24th, is in a light shade. The shading is just for grouping purposes. January 17th, whatever we finish on these 3 dates, right, whatever sections will eventually be listed here, I'll do that as we go along through the course. Those exercises on the syllabus are due Friday, January 17th. Okay. All right. Holidays are noted. Exams are noted. Exam 1, February 5th. Color coding indicates what is fair game material for that exam. So on exam 1, colored, this is shaded in blue. All of the sections of the book that are shaded in that blue are fair game material for that exam. So I hope that makes sense. And there's a discussion on the website about what exactly do I mean by fair game material. Okay. Et cetera, et cetera. Yellow for the second exam, green for the third exam. I didn't know what to do about the final exam. Everything for the course is fair game for the final exam. I didn't want to just color everything orange because I feel like that's unnecessary. Anyway, the final exam's all inclusive. Okay, how we doing? Questions? Everybody happy? Okay. Notice the exam dates are all determined. First exam, second exam, third exam, final exam. It's all set. Okay. Alrighty. Right, so that's the lecture schedule. This is a Math 216 thing. You don't need to worry about this. AHP, so this is additional homework problems. If you go to the syllabus, let's go back to the syllabus real quick. You will notice, bear with me a moment, that there are some questions on the syllabus listed as AHP. Additional homework problems. There are some ideas that we will cover in this course that are fair game for this course that aren't represented very well in the book homework exercises. And so we've written some additional exercises. So anyway, when it comes time if you see AHP, what you'll do is come over back to the course webpage for the course, and right here, additional homework problems. Boom. And here they are. Okay. All right. Okay. Let's see here. What else do we have? The grading system. Okay, so this is a big deal. Grading system for the course. It's pretty precisely defined. It's a very transparent grading system. It's relatively new. The grading system in this course is, I think this is the 3rd semester that we're using it. There's a lot of misinformation about how grades are done in Math 212 and other calculus courses. This misinformation is a result of the grading system that was for several decades before. And it had its lack of transparency aspects to it. And when there's lack of transparency, mythology ensues, right? So there was a lot of false misinformation nonsense about how grades were done in the course. So anyway, that is all passed. The grading system for the course is now really very simple. Here it is. By the way, the grading system for the course, let me go to the Sakai page real quick. Here's a Sakai page for our section, and then here is the Sakai page for the joint Sakai page for all sections of the course. If you go into the resources section, y'all won't see all this. The gray stuff is instructors only. Right here, there's a document that says Grading System 2020 Spring Math 212. So y'all should all have access to that document, and I encourage you to download that. Let me go back to, here it is. And it's a really simple system. Very simple. all of the exams, you will get a letter grade of some sort. Right? Those letter grades will be interpreted as numbers on the 4-point scale per this table. So if you get an A- on the exam, well, that's a 3.7 on the 4-point scale. We have 3 midterms in our section of the course. So 3 midterms. Those midterm exams, but the final exam, by the way, there are also other items that we'll talk about in a few minutes, but these are the weights that will be used to average those grades on the 4-point scale. Right? So I hope you all understand weighted averages, right? It's just like averaging, but anyway, if you're not clear on how weighted averages work, come talk to me. We'll talk about it. We will compute a weighted average using these weights of your various grades on the 4-point scale. And that will give you then some sort of a decimal between 0 and 4.3. That is your weighted average for the course. And that decimal will fall into one of these bins, right? So if you end up with a 3.618, that falls into this bin, which means you get an A- for the course. So it's extremely transparent, right? I mean, that's how it works, right? And end of story. So I hope that makes sense to everybody. It's a very simple grading system. And so hopefully you should understand very clearly how your grade for the course will be determined, and understand that there's really no mystery to it. Yeah, very good. Everybody happy? Any questions? Okay. All right. Okay. Right. Okie dokie. Okay, yes, let's talk about lecture recording. So again, we are recording right now. What I am saying right now will soon be up on YouTube. And specifically, here, let's see, did I do that yet? I guess I didn't. But here's my class webpage. Scroll down here. And Math 212 lecture recordings, you see right here. And there's a link right here to my YouTube channel. There we go. Okay. So, the way you will find the recordings for our course, I organize everything by playlists. So click on playlists. And we don't have a playlist for this course yet because I haven't uploaded any videos yet. But soon we will have such a playlist. And so, for example, here's the list for last semester. You'll see something that will look, I mean, it's going to grow over the term, right? But it's going to look approximately like this. You'll find all the recordings of all the lectures from the entire semester added in as we go along. And, of course, y'all know how YouTube works. Tap, observe, right? It's pretty straightforward. Okay. Right. Questions about that? Okay, so I have a couple suggestions for how to use this. So I'm a big believer in this idea. So I want you to consider annotating the lecture notes with timestamps. So here's what I mean. Here's the lecture notes for the course. By the way, these lecture notes are available for y'all to download on the Sakai site. Go to the Sakai site for this section only. Resources section. They're right there. So we'll be talking along through these notes. This will be what you'll be seeing on the screen. And if at some point you're not sure about something, you want to, you don't want to ask a question during class, but you want to be sure to come back to it later, I suggest you do the following. You draw yourself a little arrow. By the way, you can print these out if you want to work with a pencil, or if you have a cool stylus dealie or a tablet or whatever, anything that you can annotate. Make your little note, question mark, what's the deal with that? And then go down here and notice what time it is, 10:39. And just do that. Right. And then when you're looking at your notes at a later time, you're like, that's right, there was a thing here. I want to go back and listen to that part of the recording again. And you're like, yeah, but where in the recording is it? Well, there's your note. It's at 10:39. Just click forward till you see 10:39, and you're right there. So I think it's a really handy idea. This is a student-sourced idea. One of my students came up with this idea when I first started doing this recording business. So, big believer. Okay, so I hope you'll use these recordings throughout the course. I think it's a great sort of general studying tool. The idea is that, when you come to class, it's going to come at you pretty fast, right? It's a hard class. You've got to cover a lot of material. And you might not, let me rephrase that. I assume that you won't understand every single thing that I say the moment that I say it here in class. I certainly didn't when I was in college, right? So, yeah, of course, the idea is you understand hopefully a lot, some at least, hopefully a lot, of what happens in class, but there's some things that you don't understand. Those are things that you go back and study later. Well, I hope you'll use these videos as a good way to do that. Right? So you make these little annotations and such, things that I didn't understand this part. Go back and listen to that part of the recording again. Right? This is a huge opportunity. I didn't have that when I was in college, right? There was no such thing as YouTube when I was in college. So I would have loved to have been able to go back and, okay, Professor so-and-so, man, if that sounded important, what he said, I didn't get it though, and oh well. Right? That's gone. I'll never have access to, in this life, I don't get to know that point. Right? Right? So, y'all get to come back and hear it again. It might make more sense the second time. And if it doesn't, rewind back a little further. Maybe back it up, listen to that part again. That firms up your foundation a little bit. Maybe the part you didn't understand will make more sense then. Right? You might identify in listening to the recording a second time, I think the reason I'm not understanding what he's saying here is I don't really have a good grip on, he makes a reference to this one concept. I don't really understand that super well. Go back into the recordings and find where I talk about that concept. Right? So you got such a huge number of opportunities to go back and get as much as possible out of lectures. So I'm a big believer. Before exams, of course, right, as you're studying for exams, hopefully you'll be, by the way, studying for the exams as we go through the course, right? I think it's a big mistake to leave your understanding of the material in a kind of a mediocre state until 2 days before the exam and then try to cram it all in those last 2 days. That's not an effective strategy for a lot of reasons. I talk about that in the web pages some. But anyway, nevertheless, in those last 2 days before the exam, I know you're going to be doing some study, right? I certainly hope you will. And at that time, being able to go back and view video recordings again, I think it can be really helpful. And also, hopefully no surprise, it's a great way to get help while you're doing the homework. The exercise that you might be working on might be not that different from something we did in class. Boom. Right? Go watch it. That'll effectively help you with that exercise. Okay. Right. Notice I put might be made. Sometimes I have technical difficulties, and I don't know, the computer runs out of battery, or it's happened several times before that the projector fails. In which case, it turns into a whiteboard talk again, and no recording. But anyway, that's a disclaimer. How we doing? Questions? Everybody happy? All this business about attendance quizzes you can pretty much ignore, except for these last two bits. The scores will count toward your grade. I just won't be taking attendance in the form of attendance quizzes. So attendance is part of your grade. I'm going to come back and talk about that in a second. Exactly how is by an amount that I have already determined. Let's go back to the grades document, which is this one, I think. Yeah, right. Notice that in this list of weights, there is 10% for other items. Every instructor gets to determine how that 10% is allocated. And in our class, let's see here, is this the, oh no, that's the guy, oh yeah, I need to go back to, in our class, here it is, my 10% weight that I'm allocating is, homework is 7%, attendance is 3%, right? So, so attendance is a very small portion. It's at only 3%. Nevertheless, it's got to count a little bit, especially with the whole YouTube channel thing. The very first time that I posted videos of my recording, my class attendance cratered. Went down to about 20 or 30%. And I am pretty sure that what was happening is the students were thinking, oh, I don't need to go to class. I'll watch the video later. And then I'm also pretty sure that they, by later, thought, eventually, which turned into someday, which turned into never. Lots of students did poorly in the class that term, right? So not having students in class is a big problem. It was a huge problem. So I started counting attendance since then, and it's always counted for a small portion of your grade, but nevertheless something. Okay, so attendance. There's more discussion about attendance on this page. It's not hard, right? It's pretty easy to just show up to class, right? So attendance scores tend to be high, and so the expectation is also high, right? So in other words, don't make the mistake of thinking that if you have 75% attendance that'll be a C, right? That's not a C. Right, the expectation is extremely high. I assume you will come every day, and exactly how I will turn that into letter grades is, we'll see. But expect for there to be a consequence for any day that you're unexcused and you miss. Oh, y'all know about excused absences, right? The short-term illness forms, or I guess they call them incapacitation forms now. So if you are ill, well, yeah, send me a incapacitation form. That's excused. That doesn't count against you. Okay, more details in this discussion. Okay, whoa, what did I just do? Okay, all right, here we go. Last thing, I hope y'all will study in study groups. I'm a big believer. I did a lot of that when I was in college. It helped me a lot. So if you already know people in the class, cool. You got yourself a study group. Right? If you don't know any in the class, or if the people that you know in the class you don't want to study with, or whatever, right? I try to facilitate students to form additional study groups or supplemental study groups, or whatever, by organizing an email list. So if you would like to find people to study with, send me an email and say add me to the list. I will then add you to that list. I will make sure that everybody on the list has the email address for everyone else on the list. Only students who are on the list will get a copy of the list. Right? So it's relatively confidential. Right? And that's where my role ends. Y'all organize yourselves. I'm not going to break people up into groups, that's not my deal. That's y'all. Do whatever you want. So just email me if you'd like to be on the list. Okay. We okay? Any questions? Feel free. Everybody's happy with all the logistical stuff? Don't forget your assignment is to read the main page and read all of the links at the top. And then, click around. And that said, here we go in the course material. Let me remind myself. Oh, I'm sorry. The one last thing we need to talk about. The administration asked that we talked about emergency procedures. It's good to be planning ahead, I suppose, right? So they sent me this script, which I guess rather than read it, I think I'll just put it up here and then comment on it, which is more fun, among other things. So if something comes up, if you see that I am unaware, right? So if all your phones explode with, active shooter on campus, and I'm just sitting here talking about math, right? Say something, right? Yell something, right? Let me know, because I'm going to have my phone, but I keep the little thing off because I don't want to, interrupt the class and stuff. So please make sure that I'm aware. Also, if you happen to look out into the parking lot in there and you see a guy with a gun, right? I probably didn't notice. Please say something, right? Let us know. And then, by the way, if we are the source of information about the danger, then hopefully y'all have the Live Safe app on your phones, or I guess call 911 is the other way you can do that. Okay, some specifics. specific things that might conceivably be the emergency in question. If we have a weather problem, right? If there's like a tornado warning or something, this is not a good room for tornadoes, right? Look, the windows, right? This is not good. So, right outside, just to the left, there's a stairwell. And I think I've heard that stairwells are relatively safe places in buildings. Is that right? Structurally? When buildings fall, stairwells are more likely to not fall. Anyway, I think that's a pretty reasonable choice of where we can go. Y'all don't have to do what I say, by the way. Y'all are free to run screaming into the parking lot. I don't know. It's not my... But there's also, in the stairwell is also the route to get to some large interior classrooms on the first floor. You know, when you walk in the main entrance of the building, there's a great big lecture hall up there. So that's pretty good, I think, for 20. It's all interior. There's no windows. So, anyway, there's your options. If there's a fire, out the classroom door, hard right, we're out of the building. Right? I don't think we have earthquake problems, but likewise, if there's an earthquake, I don't know. They say you're not supposed to exit the building. I'm pretty sure I'm exiting the building, right? Because they say it's possible that something will fall on you out there. It's possible in here that a building will fall on me, right? So I'm making a run for it, but again, So the shooter possibility. This again, bad room. Lots of windows, lots of visibility, hard to hide, right? So I think, I don't hold me to it, right? I think a pretty reasonable choice is to go up into those large lecture halls, one of which, in particular, has a door that goes out the back of it, the really big one, the really big lecture hall, 128 in the front. If you go all the way to the back end of the lecture hall and turn left, there's a door back there that goes that exits the back of the building. And it turns out this building is a lot of people think that this is what the building looks like. Right? Here's the front of the building. This is not what the building looks like. The building actually looks more like this. Right? And that lecture hall is effectively kind of right here. The picture's not to scale. Right? But so if you go into the lecture hall and you exit, then you're out of the building. And completely concealed from every direction except for this basically empty parking lot over here. So I think this would be a pretty good place to go. That's where I'll be if there's a shooter. Yeah, and then y'all know this, but if there's a shooter, running is a great choice. Hiding is a good choice as well, and hopefully, God forbid, it comes to further than that. Okay, how are we doing on questions on this? Anybody have any questions about any of this stuff? Okay, all right. So we have 15 minutes left to actually talk about some math. How about that? Let's see, did we do all this stuff? Yeah, website. Sakai, yeah, cool. Okay, so let's do some math. Weird. Okay, so y'all have heard me say a bunch of stuff about how, there's a high expectation in this class, and I want to try to be a little bit more explicit about what I mean by, I don't just want you to memorize and regurgitate in this class. That's not what this class is, right? I mean, by the way, Wolfram Alpha can do that, right? So why would we teach a class that basically makes you into a bad Wolfram Alpha, right? Slower, less reliable, more expensive, right? So where your value comes in, and therefore where our attention in this course is going to be, is in doing stuff that computers can't do and are not anywhere near being able to do, which is to understand things, to be able to take understanding and look at new situations that they have not been programmed to deal with, right? And figure out how, with this new situation, it's got a lot in common with this old situation that I'm familiar with, and so I can take these ideas and I can adapt as necessary in the following ways, and this part of the argument doesn't work, but fix that part of the argument in whatever way is necessary, and come with a solution to a new problem that you've never seen before. Right? Computers are not anywhere close to being able to do that. Right? So anyway, I want to give you an explicit example of the kind of, what do I mean by a similar problem, and what do I mean by adapting ideas, and that kind of thing. So here's the question. So suppose you have a 8 by 8 array of squares, like that, right? And then you have a supply of 2 by 1 tiles that look like this, right? And you've got 32 of them. 32 tiles will cover this 8 by 8 array of squares in sort of an obvious way, right? But you're allowed to put them that way or this way or what have you, but it's not hard to see how you would actually go about doing this, and it's etc. Okay, so easy peasy. That's not the question. So the question is, suppose that we remove 2 of the squares. Now there's 62 squares. And I also remove 1 of your tiles. Now from an area standpoint, you've got 62 squares worth of area on your tiles, and you've got 62 squares worth of area that you need to cover. So there's, from an area standpoint, it seems like, okay, well, you just got to kind of, look, we're going to have to get a little creative here, but, you just do that when you get to that removed corner. And then I guess I have to do that. And then, I don't know, maybe something like this. And you just kind of keep going like that. Maybe that'll work, right? So does this work? And if this doesn't work, is there another way that you could kind of snake around in a different way? And can you cover these 62 squares with 31 tiles? That's the question that I want to talk about to start. And the answer is that this is a hard question. Think about how you would implement this on a computer. Right? Whenever you have a bunch of things to try, right? People's first instinct, program into a computer. Let the computer deal with it. Right? They're fast. Brute force. Right? This is, it's billions and billions of trials. And you might think to yourself, okay, well, yeah, but billions that's not that big a number these days for computers, right? So we can do that. Well, what if instead of an 8 by 8 array, what if it were 20 by 20? Well, now it's not billions. Now it's, I don't even know what the way is it, quadrillions or quintillions or heptillions. It's a unimaginably large number. And then, by the way, that's just 20 by 20. What if it's 1,000 by 1,000? Okay, it's unthinkably large. Computers cannot do that. Right? Okay. So here's the idea of how to address this. This is what I call a creative solution. I'll talk more about that in a second. And that is apply a checkerboard pattern. Right? So I'll know about checkerboards. Right? Apply a checkerboard pattern. I'm just going to use white and black because it's easier than making that. But apply a checkerboard pattern. That's free, right? Paint's not expensive, right? Digital paint's even less expensive. And having made that checkerboard pattern, notice that every time you put one of these tiles down, you always cover exactly one black and exactly one white. Every time. Exactly. And as a result of that, the number of black squares that you have covered and the number of white squares that you've covered, their difference is always 0. Now, who cares? That doesn't immediately address the question right at hand. But I'm just noting, I can color the checkerboard. I can count black and white tiles. And that difference that I'm calling I will always be 0. Okay. Now, why do I care about that? What does this have to do with the problem at hand? Well, the problem at hand, I've removed these 2 squares, and notice they're both on the same diagonal. That means that they're therefore the same color. Right? They're either both white or they're both black. I don't know which, but one or the other. Right? In which case, that means that this thing I needs to be either 2 or -2 if I'm actually going to cover this with my tiles. This thing that is unavoidably 0 has to be not 0. Not possible. End of story. Right? So this is a really powerful idea. Billions of possibilities, which, by the way, in a very, very similar problem would be unthinkably illions of possibilities. We've considered all of them by making a checkerboard pattern and making this little clever thing called I. So anyway, I like this kind of question. Mathematicians love this kind of thing. I want to point out this cultural point. This really is a creative solution, as I had it labeled at the beginning. And I mean that literally. I'm just trying to see the clock here. Oh, we're good. We got time. I mean this very literally. This is a creative solution. A lot of people think, no, wait a second. Creative is a word that you use to describe like when you are doing music and art and stuff like that. Well, it is, but it's also a word that you use to describe when you create something, right? And we have been literally creative here. We created this checkerboard pattern. That was not part of the question. We made that up. We conjured that out of our minds. That is literally creative. This I number, we made that up. That was not part of the question that we were given. It is literally creative. Right, so I think that's worth noticing. It's something that's underappreciated in our culture these days. But math is really very creative. And it's an important part of Duke math classes, I'll say. Okay. The other thing, another cultural point that I want to make is that the reason I call this I is because it's an example of something called an invariant. I call this an invariant because it never changes. Right? There's lots of different ways that I can lay tiles, but for all of them, this is always exactly the same. Right? So invariant. The reason we give this a name and call it an invariant instead of the invariant, so an invariant, is because this is not the only example of such a thing. There are lots of invariants, as it turns out. There are lots of mathematical ideas that get accomplished by identifying, as cleverly as you can, identifying an invariant, and then noticing that, oh, well, because of that invariant, I can draw a conclusion maybe because of a contradiction or something like that. Okay. All right. So, again, these are sort of cultural points. Okay, so that's what you might call a quick mini lecture on this particular problem. By the way, Math 212's final exam will have no checkerboard problems on it, right? That's not why I included this in the lecture. The reason I included this is because with this little mini lecture done, I now have the ability to show you what I mean by, the kinds of questions, the kinds of creative questions that I'm going to expect you to be able to solve on exams without my having told you how to do them. Here's let's just take them like this. So this would be an easy question. This would be what I'd call a regurgitation question. Suppose the exam question says, hey, you've got an 8x8 array and we're going to remove opposite corners. Is it possible to cover them with tiles? I guess now I'll call them dominoes. Okay, that would be an easy question, right? I mean, I told you the answer is right. It's in the lecture, right? That's it. Just pay attention, understand exactly what I told you, and be able to reproduce that on the exam. That's the lowest of bars for this course. Okay, here's a slightly raised bar. What if it were 20 by 20? That's a different question, right? A little bit. Can you take the ideas that we use to deal with the 8x8 question, can you adapt them to the 20 by 20? Well, you got to go through and think about the ideas. Can you still cover it with a checkerboard pattern? Yep. Can I still count black and white squares? Yep. Can I still subtract those numbers? Yep. Are the opposite corners still colored the same? Yep. Argument goes through. We have a contradiction. 20 by 20 with opposite corners removed cannot be covered by dominoes. What if it's 750 by 750? Yeah, well, again, you got to go through and check all the considerations, but everything goes through and it's fine and yes. Okay. Now here's something that's a little different. What if it's 10 by 20? That's not a square array anymore. But it's still with the squares and the dominoes, and it just feels like it's a checkerboard pattern kind of a solution, right? But you've got to go through and think it through. Does this actually work? All the details you've got to check and make sure, do they work? Likewise, 10 by 20, 20 by 40, 75 by 150, right? Each one of these questions requires that you check through and make sure that the arguments work. And then reproduce, adapt, represent your new argument appropriate to these contexts. And here's an eyebrow raiser. For one of these, the argument does not adapt. For one of these, it fails. And I think it'd be a nice exercise. I'm going to leave it as an exercise for y'all because we're short on time here. Oh, gosh, my eyes. Does that say 11:06? Yeah, I think it does. Yeah. For one of these, it fails. Think it through. And so I want you to not only identify which one does the argument fail, but think through what specific part of the argument that we made here with 8 by 8, what little specific little detail, in fact, does not apply. Okay. What if it's 100 by 100? Yawn. We know how to deal with that one. Okay, well, wait, but now we're going to remove, instead of opposite corners, we're going to remove non-opposite corners, like contiguous corners. Does the argument work? And if so, how? And if not, why not? And then what do you do? Right. So, by the way, I'll go ahead and give you away the answer. The argument fails here as well. So, both of these, the argument fails. By which I do not mean that it therefore follows immediately that you can cover them with dominoes. All it is you can't prove that you can't do it using invariance. Right? Just because we can't prove it doesn't work doesn't mean that it works. Right? So if our invariant argument fails, what we have is that we are back at square one, ground zero, and we got nothing. And we got to consider a whole new approach. How do I don't know. What would I do if it was 75 by 150 and opposite corners removed? What would I do if it was 100 by 100 and non-opposite corners removed? Think it through. And it's a whole new question. And I think these are worth playing with and thinking about, right? And so, again, all of these, given that the lecture addressed this specifically, all of these would be perfectly reasonable exam questions, right? These questions test whether you can adapt ideas to a new situation. This question tests, actually both of these. These questions test whether, when you're adapting ideas, whether you're actually paying attention to whether it works or not, right? Because sometimes it doesn't. And then to another extent, these questions, and then also this number 6 here, all of these are testing, can you think up clever ways to then deal with the resulting absence of a solution? Get creative with it. By the way, these questions are increasingly difficult, so I think these are pretty easy. This one's not that bad. This one's not that bad. This one's getting pretty hard here. So give it a try, right? I want to encourage you to try it, but it's hard, and don't feel bad if you can't get it. And if you're curious, come talk to me. I'll be happy to explain how to do that one. And then here's a really hard one, right? This one here is just downright crazy. If you have 3 by 1 tiles instead of 2 by 1 tiles, and you remove any 3 corners, that's a hard problem. It has a very elegant solution, though. Ultimately, by the way, the answer to this question is yes. We can use I don't know, is it a yes or is it no? We can make an invariant argument that proves that this cannot be covered. The invariant, a modification of the invariant argument does work for this one, but it's a very significant modification, and it's not obvious how you would modify it, and it's quite tricky. And again, if you have any questions, I welcome inquiries. So here's a few hints in case that might be useful. And I guess we're out of time. Oh yeah, look at that! I timed it down to the second. Perfect. See y'all later. Have a good Wednesday. See you Friday.